Hello everybody, welcome to today's lunch lecture. My name is Sebastian Kipp. I welcome you also on the behalf of the company I'm working for, which is Classman. The title of today's presentation is 50 Shades of Growing Media, and apologize in advance. I hope I haven't raised too much expectation. The only dirty thing you will see today is it's a peat moss, but I choose this title to indicate a bit how diverse growing media is. It's not just one single material. It's a huge variety of different constituents which can be designed for perfect growing media. My outline for today, I keep it rather simple, starting with where we're coming from. What were the first growing media which have been used in horticulture? How is the situation today? What are we performing today, and our perspective for the future. And this is then something with a direct link to you, because in the end I will raise a challenge for you to design an optimum growing media of the future for us, but more for that later. In the beginning there are always definitions. This one is rather simple. The EU defines a growing media as a material other than soil in situ in which plants are grown. That's rather simple. Every material where a plant can grow in, except natural soil, is a growing media. A growing media is the same thing like a substrate. You will see in the course of my presentation, I will often talk about growing media and substrates. I'm meaning the same thing. Constituent is also vocabulary which I will use quite often. A constituent is a material or are materials which are suitable as ingredient of a growing media. To give you an example of that, on that slide you see already some materials. They are not 50, but it's a selection of certain constituents which are already used for growing media. And well, we can combine a lot of them in different way to design for every purpose the right growing media or substrate. A bit of history, the evolution of growing media in horticulture. Of course, this belongs together. Growing media are the central part in horticulture because the plants are growing on it. In the past, where horticulture was not that professional like today, very simple materials were used, like clay, sand, or really pure soil, or a combination of everything. So then, with the time, the first greenhouses were built up. They're getting more and more professional. And in the 50s, there was a very important point of time. It was also kind of turning point for Classman, because we discovered that peat is the perfect material to grow plants in it. It has perfect properties, fulfilling every requirement a plant needs. So at that time, horticulture got more and more professional, and later on we also discovered that other materials are also possible for being part of a growing media. For example, coir, which is cocoa, wood fibers, compost, rock wool is, especially in Netherlands, it's a very famous material to grow tomatoes in it. So that we know, that is the situation today, but the question we want to raise today also to you is what will the future will look like? What's the growing media of the future? This is a question which is very important for us as a company being involved in the substrate business, and we are looking to answers, and that's also why I'm here today. Where we come from, we are a peat company, a traditional peat company, but we were not using peat always as a growing media. I mentioned already in the 50s, there was a turning point in history. From then on, we used peat as a growing media. But before, that was rather simple. They were harvesting peat like these both guys here in blocks, and what they did is just dry it and burned it as energy source. That was done for a long time. It's still done today in some countries. But that was the starting point also for the company Classman to produce peat. So where does peat come from? On a global view, you see the greener the color is, you will find peat bogs or peatland. They are located mainly on the northern hemisphere, namely Europe, then the Nordic countries, but also Germany, the Baltic states. North America, Canada has huge peatland areas, and we have also peat in the tropical regions. But this kind of peat we cannot use as a growing media. It's fed by groundwater, and that means it has a very high salt content. It's not suitable as a growing media. So Classmandeilman is excavating peat, especially in Germany, in Ireland, and we excavate it in the Baltic states. So this is where our raw material comes from today. First very important message for today, I'm mentioning that because many people think we as substrate industry, we are very evil. We are going into natural, wonderful peatlands like here on this picture. We destroy it and remove every plant, every animal just to get the peat. That's not the case. So we are even not allowed to touch intact, natural peatland. This is not happening. We're just excavating peat from surfaces, for example, which are used as agricultural land before. So there's no intact peatland which is destroyed for producing peat for horticulture. What is the original state of peat moss? Well, if I'm talking about peat, that means it's in the past it was a living plant. It was peat moss, like shown here in the picture. I also have a sample for you right here. You can just circle it. And it's a plant and is growing in the peat bog. In principle, the lower part dies with the time. It sinks down at the bottom of the peat bog and it decomposes over many years. And in the end, it becomes peat, which looks like this material here. So this is the original state of the peat we are using today for horticulture. It has a unique property which is very important for us. You can see that very nicely here on this microscopic image. It contains hyaline cells, shown here, which are capable to store a lot of water. You can compare it very easily to a sponge. It's able to absorb high quantities of water and to keep it. Well, that's a unique property of peat, and that's the key benefit of it for our purpose. Some numbers. Well, 3% of the Earth's surface is covered with peat bogs. That's quite a lot. But of course, not all of that is used for excavating peat. Still, 86% of those surface is in a natural condition. And this doesn't mean that the remaining 14% is used for peat excavation. The remaining 14% are mainly used for agriculture. That's very easy. People had to extend their farmland, and they just drained out the peatland in order to get more land for agricultural purposes. So that's what's happening in the past. Only 0.05% of the global available peat bogs are used for peat excavation for horticulture and still for energy purposes. In total number, that means 68 million cubic meters peat are harvested per year worldwide, but only 42% of those are used for growing media. So that's a very small percentage actually. Showing you these numbers to make you aware that we are not touching so much peatland globally as most people think. This is a profile of a peat bog. I'm showing you this to make you aware of the fact that peat is not like peat. You can see that very nicely here on the image. In the lower layers of a peat bog, the peat is heavily decomposed. It's very dense and it's black. That's why we call it black peat. The upper layers are younger. They're not that much decomposed like black peat, and we call it white peat. Well, it's not white, of course. It's light brown, but for differentiation purpose, we call it white peat. In the middle, there are also layers. We call that more decomposed white peat. And here you can see already that it's a wide variety of peat qualities which we can play around with to achieve certain benefits or certain properties of growing media. How do we excavate it? I could explain you this 1 hour long how we excavate peat. We have different techniques to harvest it. One technique is surface milling. So we just scratch the surface of the peat bog. This is done here, and then we remove it with very large vacuum cleaners. So this is one way to harvest peat. Another way would be Sodp Production. There we just cut out big blocks out of the peat bog, and we cut it into smaller blocks, which we store then in the peat bog to dry it down, and then we further process this into different fractions. So that would be sod peat. So I'm not going too much into detail because that will take too much time. But what we do in the production in the factory is very simple. We just mix together different qualities of peat: white peat, black peat, different particle sizes, different fractions. We mix it together. We mill it. We screen it, and then we add certain additives like clay, lime, fertilizer. Very important, of course, for plant growth. We mix it again to make a homogeneous mixture out of it. Then we package it, or we fill it loose on trucks, and we deliver it to our customers. So it's a rather simple process, but we have a lot of opportunities to do so. In total, within Classman, we have about 5,000 different recipes for growing media. So this shows a bit that we can play around quite a lot with different additives and constituents.
How do you make sure that there are no weeds and plants in the peat you're selling?
I am coming to that later on. We are observing that into the peat bog in natural. The peat in the peat bog is largely free of any weeds, but still it can happen that here and there are some weeds. These areas are then stopped for excavating peat. So it's our internal quality management. We make sure that the peat we excavate from the peat bog is free of any unwanted seeds, to say so. Yeah, this is just to show you how that looks like in a production facility. Here you can see some dosing units where we add fertilizers, lime, wetting agents, binding additives, and others, everything the customer or the grower wants to have in his substrate. So we're very flexible in dosing different amounts of additives. Coming back to the picture you know already, I want to move on to the physical properties of peat. Water capacity. The more decomposed the peat is, the higher the water capacity is. As you can see here, black peat has a very high water capacity. It's also more dense because it's more decomposed. It's on the lowest layer. It's compacted, so that's why it has a very high density. In turn, that means at the same time that the air capacity is much higher for white peat. So with these different properties, you can see already that we can very nicely play around with different peat qualities to achieve an optimum result for the grower. If we need more air capacity for the plants which is growing on our substrate, we add a bit more white peat. If we need more water uptake, more water capacity, we increase the share of black peat. So that are just examples to show you how we can play around. What makes peat unique? So this is now very important for the challenge I will announce in the end, because it describes the unique properties of peat: physical properties, chemical properties, biological properties. Starting with the physical properties, peat has a natural high pore volume. Pores are either filled with water or with air. This is a very, very important feature of peat. I showed you the microscopic image already in the beginning. So this is very important for us. It's a structure-stable material because it's rather decomposed already. It's nearly dead. So there is not too much further decomposition in the peat. That means it's very structure-stable material. A plant can grow in it for a long time without having any loss in volume. Bulk density is very low. It's a lightweight material. That's for us very interesting because it makes it much more easier to bring it to our growers. It's very lightweight, very important for transportation and for handling at the grower side. Physical properties. Chemical properties. It has a natural low pH, around 3.5. And that's perfect for us because by adding limestone, we can adjust the pH for every purpose of growing very accurately. We can adjust every pH we want by adding lime. Same for nutrients. Peat is very, very low in any nutrients. So by adding fertilizer, we can adjust the perfect content of nutrients for every grower. Buffering capacity is very high. Also very important for the grower. If fertilizer is too less or too high, it's a risk reduction for the grower because it buffers nutrients very nicely. It's also free of heavy metals and other contaminants. That plays an important role if you think about food safety. I will come back to that in the next slide. And fixation is probably from a chemical point of view, when thinking about alternative materials, very important feature. It has a low N fixation. That means if we add nitrogen fertilizer, it's not converted into organic nitrogen, which is not plant available anymore. If you compare it, let's say, to straw, for example, if you would need straw for a growing media, it's relatively fresh biomass. It contains a lot of free available carbohydrates. It's very attractive for microbes. They eat it up. And if you then put nitrogen on it, they will convert the mineral nitrogen, nitrate or ammonium, into organic nitrogen, which is not plant available anymore. That's a very important point when thinking about peat alternatives. I will come back to that point later on. Biological properties. We discussed that now already. It contains no weeds or other unwanted seeds. That's, of course, very important for the grower. He just wants his plants growing in the substrate, nothing else. It's free of plant pathogens. It's a biological inert material. It's not sterile. It still contains microbes, but it's biological clean. So there are no unfavorable microbes or pathogens in it. And it's food safe, and that's very important. If you buy a basil plant in a supermarket, you have it in your kitchen. And of course, nobody wants any unsecure material in a plant growing in his kitchen. So actually, you can eat the peat, and it's not harmful at all to you. So food safety, very important topic for us, because large quantity of our substrate is used to grow crops or food crops in it. I added also economic properties. Well, that's not the most important thing, of course, but for us it is. We produce substrates every year, 3.6 million cubic meters. So what we need is a material which is available in very large quantities, and peat is. It's very easy to transport, and distribution is very easy because it's a lightweight product. I mentioned that already. Processing is rather simple, and pricing is in the end a very important reason for our customers. Peat is a very low-cost material, and yeah, that's very clear. That's very attractive for our customers if they can buy a very good growing media for a low price. Second part of the presentation is where are we today? So I was now talking quite a lot about peat. The situation today is that we are using more and more alternative materials. Some of them you see here on the picture. There are much more. And I will explain to you why we are doing so. But first, it's a slide of our corporate presentation. We have a strategy within our company that we want to replace by 2020 at least 15% of our peat raw materials with alternative raw materials. Today we are at 9.1, and we're doing very well to reach this goal. I also mentioned already that a large quantity of our substrates are used for food production. We're very proud of that, and we want to increase this share as well. So you might ask yourselves the question, if peat is such a successful and perfect material, why should we replace it? And the answer is rather simple. Peat has a CO2 footprint. We know that, and we're measuring it in the peat bog, and we know that it's high. Yeah? Peat in the peat bog conserves large quantities of CO2. If we excavate it, we release CO2 to the atmosphere. This is in the end the reason why we are looking for alternative materials. We want to increase or to reduce the release of CO2 in the atmosphere when producing our products. It's also very important to know that when we use alternative material, that every material has its CO2 footprint. That's not only peat. And I want to give you an example on that. And raise your attention to the middle part of this figure. It shows greenhouse gas emissions of certain materials in CO2 equivalents. Here we have white peat and black peat. Of course, we know it's high. Yeah, that we know, that we have measured. But for example, green waste compost, it's also very high. It's even higher than white peat. And for me, that's very impressive because most people think compost is the most sustainable growing medium on Earth. You can put biomass in your garden together and you wait until it's decomposed and you use it as growing media, but it's not that sustainable as you think. It still releases CO2 to the atmosphere. Just to give you a comparison on different materials. What constituents are used today? I listed here the most important constituents which are already used instead of peat or together with peat. Wood fiber is a very nice material. We are producing that ourselves. It's a very, very lightweight, fluffy material. Compost, I've mentioned bark, composted bark, cocoa fiber, cocoa piss, rice husk, xylite. These are organic constituents. Also mineral constituents are used, many of them just to increase air capacity in the substrate. Perlite, mica, vermiculite, clay, pumice, expanded clay sand. You might have heard of that already. So these are all materials which are suitable to replace certain quantities of peat. But at this point, I have to say, from our knowledge today, we know that there is not one single material on Earth which could replace the properties of peat by 100%. So we are doing a lot of research on that topic, and this touches also the student challenge in the end. Today, we don't know any material which we could use to replace peat, and the horticultural growers, they also know that. Yeah? Coming back to the green fiber, we produce them ourselves on different production sites in Europe. It's a rather simple process. We just use wood chips, we mill them, and in the end, we receive a very nice, fluffy fiber out of it. It fulfills also already some properties of peat, for example, very low salt content, very low pH. The disadvantage is here that it doesn't store or absorb so much water like peat does. But if you need a substrate with some good drainage, for example, with a lot of air in it, the addition of wood fiber would be very good. So therefore, we still use it. Compost, we are producing also by ourselves. We're using 100% green waste compost. Other biological waste composts are not that optimum because they mostly contain a lot of salts, and salts we don't want to have in our compost to a higher amount. Those are certified processes, and we control it very intensively for heavy metals, human pathogens, residues of pesticides. It's very important to ensure a good quality when using compost because you never know what kind of material you receive to your composting facility. I mentioned already that within research and development, we have spent a lot of years already in testing different alternative constituents or peat alternatives. Some of them are just listed here to give you an impression how diverse this field is. None of them was suitable to be part of a growing media because certain disadvantages, very high nitrogen fixation, very high contamination with fungi. There's always a disadvantage among those materials. And this is just a snapshot of what we have already tested that I can promise you. Okay, I mentioned already we have a lot of different recipes, even in our company, like 5,000 different combinations of constituents and additives. The question is now, how do we select the optimum combination of constituents for growing media? And this depends on several factors. First factor, environmental conditions at the grower site. Is it in hot climate? Is it in colder climate? This has, of course, a huge impact on the choice of a growing medium. The intended application, very simple. What kind of plant is growing in it? Different plants have different requirements for a substrate. A ratio between air capacity and water capacity, very important. Do we need more water storage in the substrate, or do we want to cultivate more dry and we need more air capacity? Do we need a structure stable substrate? For example, shrubs and trees are plants which are growing in one substrate for a longer time, and therefore we need a very stable substrate. What irrigation system is used by the customer? Ebb and flow, sprinklers, there are different opportunities to water plants, and that also has an effect on the growing media. Is a customer or a grower price sensitive? Yeah, in some segments you might know that. Cut flowers, for example. is a segment which is very sensitive for pricing. Isn't grower a self-mixer, meaning he's maybe using local raw materials and just want to add certain quantities of peat to his mix. What are grower preferences? Horticulture is a very traditional business, so we often observe that growers using substrates since 20 years, they will never change that. So that we have to consider as well. Cultivation behavior, same thing. Yeah? Growers are used to certain ways of cultivating plants, and we have to look at them very carefully to recommend or select the optimum combination of constituents. Some images of applications. Where are our substrates going to? Vegetables, of course, very huge segment, and there I'm not talking about the final vegetable in the field. The young plant is growing in substrate. It's mainly based on black peat, and from that we form a blocking substrate, we call it. It's a block of black peat. You can put a seed in it, and the young plant is growing in it. That you see on the picture here in this greenhouse. Later, this block is then transplanted automatically into the field, but the young plant is always growing in substrate. Pot herbs, you know. I could bet that at least half of you have a basil plant at home in your kitchen, and it's, of course, it's a very high chance that it's our substrate in it. Mushrooms, also very interesting. It turned out that there's no suitable material for mushroom casing soil where a mushroom mycelium could grow through, others than black peat. So yeah, they're still using black peat for growing mushrooms, especially champignons. Soft fruit is a rising segment. More and more growers are moving from soil cultivation, it's an example of blueberries, into container cultivation shown on this picture. Why are they doing so? It's because of climate change. The risk is too high to grow a blueberry plant into the soil because some years getting very hot and dry, some years very red, so they realized that it's better for them to reduce the risk and grow a blueberry plant in a container. Shrubs and trees, also a very big segment, also growing in substrate. And here we need a very structured, stable substrate, because you can imagine these kind of trees are standing in the substrate for a long time. Pot plants are everywhere. Same for bedding plants. Yeah? Especially in the Netherlands. I hope you are aware of the fact that it's a huge market for bedding plants and pot plants. Some special applications, I don't want to put the focus on that, but we also can use peat as bedding material for animals. They really love to live on peat instead of straw, for example. Golf courses is also a special application. We even delivered peat to a musical in Germany, with Shakespeare's Hamlet. They want to have peat for the decoration of the musical. That's a very minor application, but we would call it a special application. So now it's going to be very interesting because I will now raise a question: where are we going? I have no idea. I hope that you will, in the end, answer this question at least partly within the student challenge. The big question which drives us is, what will be the future of the growing media? And I just want to give you a bit exotic example on that. Hilton hotels, you all know. Within the Hilton group, we have about 5,000 hotels, 800,000 rooms. It's the second largest hotel group on Earth. Next year they will have the 100 years anniversary. I'm mentioning that because within the substrate world, our company is not too different. Well, we are not Hilton, but the numbers are a bit comparable between the hotel business and the substrate business. We are producing 3.6 million cubic meters substrates, and billions of plants are growing in those substrates. And we are the Hilton of the substrate industry, if you say so. And
second largest.
Not the second largest. It's probably the largest. Numbers are changing, but we do not know exactly. But yeah, you could say so. We had our 100 years anniversary in 2013. That's also something which is very similar. But I'm choosing this example to give you an example how fast things can happen. What happened to Hilton? Airbnb. If you now use Airbnb, you can choose between 4 million accommodations, not 800,000, it's 4 million in 140 countries. And they did that in 10 years and not in 100 years. That's a very, very great example, and we call it a disruptive innovation. It's a very simple business model, but within 10 years, they made it that every hotel group struggling and fighting with Airbnb because they are a very big competitor in the meantime. So we ask ourselves the question, who will be the substrate Airbnb? It's rather simple, but we as a company, we have to look at that because things can happen very fast, and we want to be in place if a disruptive development hits us. We want to be in place, and we want to be part of that, and that's also why I'm here today, trying to communicate or collaborate with you guys to listen to your ideas, because we are within the company. It's always good to open our eyes and listen to externals, really to see trends. What will be the growing media of the future? And of course, this depends first of all on the cultivation system of the future. How will that look like? I have no idea. There are many mega trends in place. I mentioned already that there's a strong trend from soil cultivation into food cultivation due to climate change, but also due to lack of space. Automatization, mechanization, digitalization, big words, and they are everywhere. And maybe a greenhouse of the future will look like that. Conveyor systems, sensors everywhere, drones, robots, who knows? So we see that very realistic, and why should not that happen also in horticulture? It's everywhere. Big data becomes very, very important. So it's also, in the meantime, it's all about data. Everybody's collecting data and making business models out of it. Local for local food production, organic production becomes very important. People like to have their food grown just in the neighborhood instead of carrying it around the world. So these are trends we have to observe, and we look at that very carefully. Coming back to the question, what will be the future? There are systems nowadays like hydroponics, aeroponics, aquaponics. Nowadays this is a bit limited to leafy vegetables, lettuce for example. But who can promise it that in future not every vegetable will grow in hydroponics? We don't know, but you have to look at that. Vertical farming is a very famous way to grow plants nowadays. So maybe we won't have a greenhouse in future. Maybe there is only local production in big cities growing vertically under artificial light, no sunlight. This is already working today. It's a bit too expensive nowadays still, but nobody can promise us that this won't be the future. Urban farming, maybe we will have such food greenhouses in big cities instead of living places, which provides city people with food. This can happen. And all of that ways to grow plants has an influence on effect on the choice of a growing media, and that's why it's such important for us. So we have a very specific question for you. So this is the definition of the greenhouse challenge and the part Sustainable Substrate Award, which we announced today to you. Our question to you is, can you design an innovative growing media that allows high yields while it's made of sustainable circular raw materials? So please note this question. That is I hope you will work on next time. To motivate you a bit in collaborating with us, we announced a prize award of €1,000 for the winning team. We will have jury of internal teams of Classman together with the Wageningen Greenhouse Challenge team. We will decide what's the best promising idea. We will look at the expected growing performance. Is the material, the growing media you design, is it sustainable? Is it really innovative and disruptive, or do we know that already? What technology is used? Is it modern technology? Can we scale it up? Well, that's for us as a company, of course, very important. Can we build really a business case out of that? And does it fulfill physical, chemical, biological, and economical properties of the growing media which we are using today? So this is now your challenge. I hope you will work hard on that and present us some very, very nice ideas. And we are really curious to see what you are developing. In the end, just 2 slides from our own company. You're young people, you're students. Maybe in future you're looking for job opportunities. Company where you can write up a thesis or something. We're always looking for horticultural engineers, agricultural scientists, business specialists. So these are people we really are looking at. And well, if I could make our company a bit interesting to you, I really hope that you remember us when you are in the stage of looking for an internship, a thesis, or a trainee program, or even a job. Please visit our website, look for career opportunities, and maybe we will see in future in the substrate world. So that was my presentation. I hope, well, it was a very condensed package of information for you about growing media. There are a lot of more information, but I really confident that is enough to give you an impression what is important for designing perfect growing media. And I will now leave it with you to develop something really innovative. Thank you.
Do you have any questions to Sebastian?
Maybe a rather specific question, but we maybe want to grow legumes, and legumes grow root nodules. But we were wondering if certain substrates really inhibit the growth of root nodules, and some really might promote it.
Well, there's a big trend. Maybe the peat-based substrates have not, but there's a strong trend towards microbial additives, for example, and those can have an effect on the growth of nodules. What you just were asking. So think about additives. It's not only peat, which we use. We can add whatever is needed to the substrate. If it's a powder, is it a liquid or whatever, to enrich the substrate with certain properties. That's possible. There was a question?
In one of the slides I saw that you have a organic certified substrate.
That's true, yeah.
But well, as far as I know, organic agriculture is not allowed in substrate.
It's allowed. It depends on there are a lot of grower associations. Organic growers are part of that, and that depends on the country. Most regulations tell us you can only use maximum 70% peat in an organic substrate. In some markets, UK, Switzerland, they are very, very far in that. They even want us to replace 70%, for some crops even 100%, peat with alternative materials. So this depends pretty much on the plant which is cultivated and on the market. It's possible, but we also know that replacing 100% peat, it's a high risk for the grower. You really have to observe your cultivation very, very, very carefully, and you won't achieve same yield like with a conventional substrate in the end. That's also very clear, but it's a way to grow plants organic.
I saw in some slides that you showed that you provide some substrates that are specific for, I don't know, mushrooms or some kind of plants. How specific is for the species, or because, for example, you mentioned, especially this substrate is really specific for this kind of mushrooms. So how specific it could be for the species, or for general, or some general growth burdens and boulders?
In general, of course, there are overlaps. Certain substrates are also suitable for other plants. In case of mushrooms, well, I'm mostly referring to champignons. This is the dominant mushroom, and they need only black peat. It's a different system. They have a compost in the lower layer. That's really compost, which they inoculate with the mushroom, and on top there's a layer of black peat, and the mycelium will grow through it. So for mushrooms, there's no other opportunity instead of using pure black peat, for example. But of course, that might of course possible. You can grow a huge variety of vegetables in the same substrate. So it doesn't necessarily mean that every crop has its own substrate, but we can play around quite a lot. There are also different varieties within one crop with different demands, fast-growing varieties, rooting, varieties with strong root growth, and therefore, of course, you can adjust the substrate, and this is what we're doing together with the grower. Yeah? We are in close collaboration, close talks with the grower. He's observing, he wants to improve, and then we add certain other materials, we increase fertilizer, we reduce fertilizer. This is what happens every day.
So do you test also clothes, like waste from clothes?
Not yet. We have thought about that. Yeah, there's a huge market for used clothes, of course. Problem will be that it contains color, and where color is, same for newspapers, for example, contains heavy metals very often. And many crops are very sensitive to heavy metals. We also have regulatory hurdles for heavy metals, so it will not be very easy to really use used clothes for growing media. But that goes in the right direction. I'm really confident that you open your mind. Very good. Any other question? All right. Thanks you again, and have a good lunch. This is a lunch lecture, so I'm pretty sure that you're looking forward for having a lunch.
I have a question. You already moved from one market to another, from the burning peat.
Yes, that was.
Why do you want to
Yeah,
insist in
that
this plant market?
Yeah,
that's
that's.
the way you kept alive quite.
And we're very happy that this happens in the history of our company, because it shows us this could happen again.
Yeah.
Maybe in 10 years we will sell something completely different, like it happened in the 50s, where we stopped burning peat, we used it for horticulture. Who knows what happens in the next years? All right.